Over 11% of the world's uranium reserves lie in Namibia. Why does a nation with massive offshore diamond mines struggle? The geology implies wealth. However, only 2% of the land supports agriculture. But this is just the beginning. The Namib Desert advances relentlessly, consuming the soil. One can notice how sand encroaches on habitable zones. It seems obvious to look inland, but in reality, the solution came from the cold, dark ocean depths. Seaweed farming emerged as a lifeline. Can a fragile marine plant save a dry country? The process is only gaining momentum. Green fronds sway in the currents, offering a new path. The harvest begins a new industrial phase. 45 degrees Celsius by day rapidly plummets to below 10 degrees at night. Why is this land considered more extreme than the Sahara? At first glance, the scorching sands look similar to other arid zones. But the Namib Desert in southwestern Africa holds records that surpass even the icy Gobi. It stretches over 2,000 kilometers along the Atlantic coast, shaping the entire climate of Namibia. But this is just the beginning. One can notice how the towering sand dunes rise nearly 300 meters high toward the sky. It seems obvious that deserts are dry, but in reality, the dryness here is absolute. Annual precipitation is just 2 to 10 millimeters. This figure is far less than the Sahara and dramatically lower than the Gobi. Consequently, this creates an environment positioned at the very edge of survival. It is visible how the heat distorts the air above the endless sands. The Namib is not merely a desert. It stands as the desert of deserts. The ancient terrain waits for the next cycle. 824,000 square kilometers is the vast area covered by Namibia. Why is the story of agriculture here more worrying than ever in such harsh climatic conditions? Deserts do not cover the entire country, yet the remaining land is hardly more livable. Only 2% of the national territory possesses sufficient water for stable cultivation. This is an extremely small figure for such a massive region. One can notice how most rivers appear only after heavy rainfall, which is exceedingly rare in these latitudes. At first glance, the terrain holds potential, but in reality, for many months of the year, waterways are nothing more than dry riverbeds offering no value for agricultural production. Farming is still practiced here, but only on a sparse scale. It remains in complete dependence on unpredictable natural conditions. Consequently, the agricultural sector is currently capable of supporting only about 25 to 40% of the population. But this is just the beginning of the challenge. The population itself grows at an average rate of 2% per year. It is visible how the pressure on resources mounts while the amount of arable land remains almost unchanged. With population growth outpacing the expansion of cultivable land, the nation has no choice but to find ways to transform barren land into fertile soil. Failing to achieve this means the agricultural sector will soon face the risk of total collapse. The situation requires immediate technical intervention. One of the most nutrient-rich marine ecosystems on the planet lies just offshore. Why does this matter for the arid mainland of Namibia, where cultivation is nearly impossible? Traditional agriculture seems disconnected from the ocean. The answer is the cold Benguela Current, carrying vast amounts of minerals and nutrients up from the deep ocean floor. This flow nourishes an entire kingdom of seaweed stretching along the southern African coast. But this is just the beginning. One can notice how the seaweed kingdom expands rapidly along the shore. The plants absorb minerals directly from the water, accumulating a remarkable store of nutrients. At first glance, this seems like simple vegetation, but in reality, it contains potassium, calcium, and rare trace elements that Namibia's soils are severely lacking. Because of this composition, the material opens an unexpected lifeline for the parched land inland. When harvested and composted properly, the seaweed becomes a nutrient-rich organic fertilizer. It gets more complex further on. The mixture restores degraded soils and improves water retention. This process effectively reactivates microbial life. The cycle completes its connection between ocean and earth. Thus, an unforeseen solution emerges, reviving the land with seawater. 6,400 hectares is the target size for the underwater forests in the next phase of development. When the idea of bringing life from the sea onto land was first proposed, many people in Namibia were skeptical of its feasibility. But just a few years later, what was once dismissed as vague and unrealistic has become a fully operational model with heavy infrastructure. Off the coast of the town of Luderitz, the company Kelp Blue deployed its first cultivation rafts, officially marking the beginning of Namibia's large-scale underwater forest farming model. This project is now considered the first industrial-scale kelp farming model on the entire African continent. Why is the placement of these rafts so critical for the harvest? The ocean expanse seems uniform from the surface, but the submerged mooring lines anchor the garden precisely where the cold Benguela Current flows, ensuring the seaweed absorbs abundant nutrients while growing vertically throughout the water column. On a weekly basis, teams of marine engineers and divers submerge to inspect the growth rates of the plants. One can notice how they carefully trim only the mature sections before bringing them aboard the harvesting vessels. At first glance, it seems like a simple gathering task, but in reality, speed is paramount. The kelp is transported directly to shore on the same day to prevent natural decomposition caused by prolonged exposure to air. It gets more complex further on. The facility in Luderitz receives the fresh raw material without delay. All raw material is thoroughly washed, finely ground, and fed into a complex biological fermentation system. The kelp is then separated into specialized product streams, such as biological extract solutions and biostimulants for agriculture. And this is not the limit. The system produces microorganic formulations to improve soil structure, as well as carbon-rich biological byproducts serving industrial uses and carbon dioxide storage. Because the model harvests only mature portions, much like pruning trees in a forest, the process does not degrade marine ecosystems. In addition, all farming activities are conducted outside sensitive habitats to avoid impacts on native marine wildlife. As of the year 2024, Kelp Blue has deployed more than 30 hectares of kelp farms. Thus, the foundation for Namibia's ocean agriculture industry is firmly established. 25 to over 60% is the recorded increase in yield on experimental farms. When the first batches of fermented seaweed were processed and returned to the fields, farmers monitored the changes closely. Lands once cracked and barren from drought began to change color before their eyes. The pale, compacted soil became looser and retained moisture for longer periods. But this is just the beginning. After just 2 to 3 growing seasons, the crops began to take root firmly. Why did varieties like maize, millet, and leafy vegetables thrive? At first glance, growing such crops seems impossible in a country where regions receive only 2 to 10 millimeters of rain annually. But in reality, the seaweed treatment allowed the soil to support stable yields even during extreme dry spells. One can notice how the soil ecosystem itself came back to life under the surface. Microbial activity surged significantly, and earthworms reappeared in the earth. It is visible how the structure of the ground regenerated, reducing crop failure rates sharply. It gets more complex further on. Farming models using seaweed fertilizers help reduce dependence on costly imports. Therefore, some projects have recorded input cost reductions of 30 to 50%. One can see a vision of a more sustainable agricultural future opening up in a land once considered uninhabitable. From the cold Benguela Ocean to the cracked fields inland, seaweed acts as a vital link. It has become an unexpected green miracle, bringing harvest back to a nation standing on the edge of widespread desertification. The cycle of production stabilizes here. 50 to 60 meters is the vertical height achieved by the specific organism Namibia chose to revive its drylands. Among dozens of potential seaweed species, the country selected Giant Kelp, scientifically known as Macrocystis pyrifera, which stands as one of the fastest-growing organisms on the planet. One can notice how these plants form vast, swaying underwater forests along the coast. But this is just the beginning. Why exactly did giant kelp become the key solution for soil restoration? It would seem that any available biomass could serve as a simple organic fertilizer, but the answer lies in its exceptionally rich nutritional structure, which is unavailable in other species. Because this plant contains more than 60 trace minerals and a wide range of amino acids. At first glance, it looks like ordinary seaweed, but in reality, it holds bioactive compounds and easily decomposable organic carbon that actively stimulate plant growth. It is visible how the processed compost physically improves soil structure and enhances water retention capabilities. The material boosts microbial activity and significantly reduces the need for chemical fertilizers. It gets more complex further on. However, these factors are critical for a country where only about 2% of the land remains suitable for cultivation. The cold Benguela Current drives the development of these underwater forests, providing a nutrient-rich environment for rapid expansion. Thanks to these conditions, giant kelp grows up to 30 centimeters per day. One can observe how the plant creates a nearly limitless and renewable resource for the region, laying the foundation for an entirely new agricultural model. Consequently, the dead soil slowly returns to life through the natural power of the ocean. 60 centimeters of vertical growth every 24 hours. This is the relentless pace at which kelp expands in the cold, nutrient-rich waters of the Benguela Current. These offshore sites are not merely simple production lines for fertilizer, but complex biological structures rising directly from the seabed. Towering trunks stretch for tens of meters toward the surface, forming a dense, swaying canopy that mimics the structure of terrestrial woodlands. One can notice how the thick vegetation creates a shadowed environment, acting as a massive biological machine. But this is just the beginning of the transformation. The ecosystem actively filters the water column day and night. Why is this dense vegetation termed an ecological conductor of the ocean? To a casual observer, the thickets look like a chaotic barrier to water movement. However, the kelp physically traps vital nutrients that would otherwise be swept away by currents into the deep ocean void. This retention fuels a localized food web where fish, shellfish, and countless microorganisms find shelter within the tangled fronds. At first glance, this massive carbon absorption appears to be a flawless climate solution. But in reality, significant controversy is surfacing across the United States and Europe. Many environmental organizations question whether these forests genuinely store carbon at a meaningful scale, or if they serve as greenwashing tools for marketing carbon credits. Experts argue that as seaweed naturally decomposes, much of the captured carbon releases back into the water rather than sinking to the seafloor for long-term burial. It gets more complex further on. New possibilities for marine tourism are already opening up in these waters. It is visible how diving routes are being mapped through the kelp corridors, offering a unique underwater experience in Africa. Yet, beyond the tourism and the global climate arguments, the physical benefits for Namibia remain immediate and tangible. The farms growing near Luderitz provide essential jobs and generate raw materials specifically needed to revive agricultural fields that have long been left barren. The nutrients captured underwater eventually find their way to the exhausted soil. The process continues cycle after cycle, steadily supporting a coastline on the brink of recovery. 90% of the nation's total fisheries export value in Tanzania now comes from the harvest of a single marine plant. The transformation driven by seaweed does not stop in Namibia, but extends to the eastern side of the continent. Kenya and Tanzania are undergoing a quiet but profound change powered by this humble resource. In coastal villages of Kenya such as Makwiro and Kibuyuni, agriculture had been crippled by years of prolonged drought. One can notice how the arid landscape forced communities to seek alternatives, but this is just the beginning. Farmers began cultivating seaweed on hanging lines in the early 2000 era. Why did the focus shift so heavily to marine cultivation in these specific regions? Traditional farming had become nearly impossible due to harsh climate conditions. This specific plant requires absolutely no soil and no fresh water, utilizing only the sea and sunlight to thrive. What started as a few small lines near the shore gradually expanded into a major operation. By the year 2022, Kenya harvested nearly 100 tons of seaweed. This massive harvest generated more than 30,000 United States dollars in income, revenue that had previously been unimaginable. Dried seaweed is processed into food powders, soap, and shampoo before shipping. It gets more complex further on. Consequently, exports now reach global markets in China, France, and the United States. At first glance, this looks like a local subsistence activity, but in reality, it creates an entirely new economic sector for the poorest coastal communities. Tanzania is even more striking in scale, standing as the third largest seaweed producer in Africa. One can observe that around 25,000 farmers are involved in the daily work, and most of them are women. It is visible how once impoverished fishing villages have evolved into seaweed processing hubs. These centers generate thousands of jobs in cosmetics, food production, and bio-based products. As farmland degrades and job opportunities shrink, the industry acts as a lifeline for tens of thousands of families. Thus, communities threatened by climate change have discovered a new path to livelihood. 2024 marked the ban on plastic straws in Namibia, with single-use bottles following in 2025. Large amounts of waste continue to wash ashore, accumulating on the coasts despite the regulations. Why is a new material substitute necessary alongside these bans? Laws cannot instantly eliminate the debris circulating in ocean currents. Seaweed is emerging as the functional answer to this persistent environmental challenge. Reviving degraded land is just one capability of the plant, but this is just the beginning. Scientists from Flinders University in Australia and the German company CH Bioforce extract sodium alginate to create a bio-based coating. One can notice how the raw substance processes into a thin protective film in the laboratory. The material offers oil resistance, water resistance, and heat tolerance comparable to petroleum-based plastics. At first glance, the result looks like synthetic packaging, but in reality, it is fully biodegradable in nature. This innovation aims to replace plastic coatings in food packaging. The solution integrates seamlessly into the ecological cycle. 2% is the exact fraction of land in Namibia suitable for traditional farming. The remaining territory features fields cracked by severe drought. At first glance, agriculture seems doomed here, but in reality, the answer lies in the water. The cold Benguela Current flows ceaselessly. Why does the solution depend on this freezing stream? The land remains arid and dry. The current creates the ideal environment for towering columns of seaweed to grow. One can notice how the aquatic plants sway in the nutrient-rich tide. But this is just the beginning. The country finds hope not in the soil, but in the ocean depth surrounding it. Thus, the harvest cycle continues underwater.